Well, welcome everyone
Hi.
to the 8th podcast ever
Of Daisies Off
Daisies Off
Duty.
Duty. We have a very special guest, Owen, here today.
Hi.
Would you like to go ahead and introduce yourself, like your name, your major?
Yeah, sure.
something
I'm
interesting?
Owen. Yeah, hi. I'm Owen Fry. I'm a mechanical engineering student here at the University of Guelph. The main thing I guess I do is I'm the suspension lead on the race team here, the FSA team we have. Yeah.
Very
Okay, cool. So where do you start from?
Well, what got you into the race team? How did you just come about to Guelph and mechanical engineering?
Yeah, that's actually a good question. So I've been kind of really interested in cars, I guess, since maybe I was around 14 or 15, kind of gearing up to getting my driver's license. I kind of started digging into cars a lot and found out there was actually something I was really, really interested in. And so when I was kind of applying for different schools for mechanical engineering, and also I was applying for mechatronics engineering, actually a lot of them, but one of my main criteria was that the schools had an FSA team on them.
Oh, I see.
Because I'd kind of been looking into how to get into motorsports as a career, and the biggest thing you can do is in North America we call it Formula SAE, in a lot of Europe they call it Formula Student. It's the same thing.
Oh, okay.
And the biggest thing you can do is go into a program that has one of those teams and join that team. So I've actually been on that team since the summer before I started school, because I reached out to them before.
Even before university
started.
So you've been there for 4 years now?
Yeah, it's been getting up there.
Yeah, wow, that's crazy.
Mm-hmm.
Interesting. Yeah, because I went down because I'm planning on joining it this year. So I went to the meeting last week and I'm trying to join the embeddeds team. So
embedded, yeah.
Well, how much? So when did you become a lead for the what was it? You were
I'm suspension lead.
Right?
Yeah. So after my second year on the team, the previous suspension leads who had kind of been mentoring me for that first bit of my degree, they graduated or I think they were actually moving into their last academic semester. But anyways, we want to always keep kind of not a rotating door, but always invite new people to become the leads before the previous leads are completely graduated and out of school, so that there's a bit of buffer time there for knowledge transfer to take place. So I kind of started I think after my second year.
I see. And how many hours did you have to put into because I don't know if this is true, but do they vote you in to be a lead, or how does it work?
Yeah, we have a democratic kind of system that we have set up. So for this semester, actually, I got voted in along with a co-lead.
Oh, okay.
One of the slightly young. I think he's a year younger than me. I've been kind of showing him the ropes, and so now he's gotten to the point where we can actually take on a lot of the suspension design as a pair. So I'm co-lead along with Korab Zalami. He's the other.
And how many hours did you put in before you were a lead, I guess?
Yeah, I mean, I think part of the reason I became a lead is just because I put in a lot of time, kind of in the beginning.
Yeah.
It ranges depending on, the time during the season. There's a lot more crunch towards the end, but anywhere between 30 and 50 hours sometimes, and there's some more laid back weeks, but you can put a lot of time in. We don't expect that of all of our members, but for the leads there's a little bit more, I think, responsibility there.
And how do you balance that with all the school stuff that's going on, and how many courses do you usually take in a semester?
So I've been taking full course loads. That's usually 5 or 6 courses, which is ridiculous, by the way. That's what we have to take, but it's sometimes a bit of a challenge to balance. But one of the actually interesting things that I found is a lot of the stuff you learn designing a race car is actually very applicable to the courses we're taking. So, when I was taking material science, a lot of those concepts made sense because I had already been learning about how we heat treat some of the parts on our race car, or why we select, the alloys that we do for the parts on our car. So even before taking material science, I'd already been sort of exposed to some of that stuff. As well as a lot of the mechanics and dynamic stuff that we do on the race team is very applicable.
Right.
So in that regard, it's not like I'm considering all of the time that I spend on the race team as time away from pursuing learning in my degree. I think they kind of go hand in hand.
Okay. So this summer you went to Michigan, right? What was that?
Yeah. So we went to 2 competitions over this summer. The biggest one in North America is the Michigan event. which happens a little bit later in the summer. And then earlier on, we had gone to New Hampshire for, they call it Formula Hybrid.
Yeah.
And there are a couple hybrid vehicles that compete there, which is really cool. That's actually a whole other like challenge to try and make. We were making an electric car. This is our first time competing with an electric car. But the hybrid event is a couple hybrid cars, but then they've also kind of modified the rules a little bit to allow fully electric vehicles to still compete in that competition.
I see. Okay.
Under, like, I think that it's the rules are slightly different than Michigan, but we found that if we designed a car to compete in Michigan, it didn't require very many changes to be legal for the New Hampshire competition.
Okay.
Yeah. So we did two big competitions over the summer.
So the cars that you guys make, it's an electric car.
Yes.
Have you guys ever thought of making a non-electric car?
So that's actually how the team got started.
Okay.
I think when did we get started? Very early 2000s, slightly before I was born. But we've been going for a little while now. And this is the first time we've done electric. All the other previous cars have been combustion.
Oh, wow.
So for a very long time, we were using 4-cylinder Suzuki motorcycle engines. Yeah. And then in 2020, we were planning on, this was just before I joined the team, but in 2020 we were working on a single-cylinder powered car with a KTM engine.
And what was the reason for the switch from a combustion engine to an electric car?
For the switch for combustion to electric, the idea there was a lot of automotive engineering jobs are now, even if you're not working directly as an EV, it's a skill that is kind of necessary to have as automotive makers transition into hybrid vehicles. Like, they still have electric motors, and then fully electric vehicles, obviously. Like, we have members in the team doing, co-ops at Tesla, and really every major automotive manufacturer is, at least doing some stuff with electric vehicles. So there's that aspect of it that I think we're just kind of preparing the students on the team to be a little bit more, have some more modern skills. The way I like to see it too, though, is there's some unique challenges that you have to solve to build an electric vehicle that aren't quite present if you're doing a combustion vehicle or an ICE vehicle, as we call them. So, your traction control is maybe a little more, involved. Like, a lot of the teams, I don't think, run traction control on the ICE cars, but like, it's kind of something you need to think about for an EV. And the teams that move into, we're not quite there yet, we just still have a single motor, but the teams that are running multiple motors on their car, 2, 3, 4 motors, you start thinking about how all those motors interact with each other, and you can send power to one versus the other, or more or less, and torque vector, and basically try and extract the most grip out of each tire on the car. You have four tires, so sometimes you can extract a little more grip and accelerate a little bit faster using that, and that requires some very advanced algorithms and stuff. That's not really something I'm super involved with, but like, you're talking embedded or any of the software systems on the car will actually be in charge of that stuff. So there's really interesting things you can do with that that you just don't quite have the opportunity to do with combustion.
Why would you need more traction in an EV rather than your ICE?
Yeah, so at the end of the day, a big part of the competition is design, but there is still some competition to it. So there's still an autocross event and an endurance event, and you win those by being fast. Okay. So when you're in some sort of steady state cornering maneuver, let's start there. Not each tire might will be loaded up slightly differently. It'll have a different, if you want to call it a weight or force pressing it against the ground. And tires, the amount of grip you can extract from a tire depends on how hard it's pressing into the ground, but it doesn't do that in a linear way. So using some models, like you have to do a lot of testing with your tires, but once you have a very good idea of what the tires are doing, you can push each tire basically to its limit, to where it's making the peak amount of either lateral or longitudinal force, depending on whether you're trying to accelerate in a straight line or get around a corner faster. So I guess in the lateral sense, you're not really influencing that a whole lot with the motors. It's more a function of your suspension. But in a straight line, or in combined, what we call slip angle and slip ratio. So one of those describes the tire deforming in the lateral direction. One describes it deforming in the longitudinal direction. I'm not sure how in the weeds we want to get on this podcast. But
as much as you
want. Okay, but
it's going to be the most informative podcast we've had.
Okay. Yeah. So there's situations when you're taking a corner, like trail braking or accelerating out of the apex of a corner, where the tires are being asked to both keep the car on its trajectory around the corner, which requires some force inwards towards the corner. Centripetal force is kind of the idea there. Where you're asking the tires to do that as well as move the car forward, because the faster you exit that corner, the faster you can get to the next corner. Yeah. So when you're dealing with that combined scenario there, where the tires are being asked to do both of those things, it can be useful to know how much you can push those tires before they start breaking traction. So you need some advanced algorithms to do that, and then you also need to, even if you know how much force you can get out of those tires, unless you have 4 individually controllable electric motors, you're going to struggle to keep all those tires right there. But we're not there yet. We just have a single motor again.
Right.
But some of the teams, and eventually we want to get to this point where some of the teams are running 4 motors.
Right.
And you can exactly get each tire doing that.
Would you say you learned all of this from the Formula team, or did you have prior knowledge? How did you get to being so knowledgeable?
So smart.
I'm not sure smart's the right word, but
well, you guys are doing actual engineering, right?
Yeah.
And a lot of people don't get to that until they actually go out of university and get into a job. So the fact that people who are part of these clubs are already doing that, so it's
Yeah, I think you can make a point there, that we're doing real engineering already to some extent, yeah. But we're definitely building on a legacy that this team has had for a very long time. I don't think that if you took the people that are on the team right now in isolation with no previous experience working on race cars and no not this 20+ year old team history behind us, and you just asked Saul to build a race car right now, maybe we could do it, but it definitely would not be something as functional, or it wouldn't be what we can build now, because we are building off of designs that have been around for quite a while, right? We're always iterating and making it just a little bit better. I've lost my train of thought a little bit. What was the original point?
Did you learn it on
Right, yeah. Where did I learn all this stuff? Yeah. So there was definitely a bit of learning I did myself before entering university. Actually, it's all kind of collapsing now. But for the past maybe 5 years, there's been a real, maybe more like 10. There's been a really good community on YouTube of content creators doing just all sorts of car content. Some of it has been really interesting, and that content kind of geared towards I feel high schoolers, people who are maybe turning 16, getting into buying their first car. There's a lot of content kind of around there to hype those kids up and really get them excited about car culture and stuff. So I was there. That was kind of a lot of the content I consumed in high school, which, looking back, maybe actually didn't teach me all that much about cars, because watching those videos back now, it's not a lot of that information was super correct or useful, but it definitely got me excited about cars and car culture, which I'm all for that. I'm not trying to diss those YouTube channels, but they at least put me in the position where I was not curious about cars, and knowing that I wanted to do engineering, which had been something my family has sort of been telling me for a very long time, was you need to do engineering. So I was thinking, okay, how can I combine, I really like cars, and I really want to do engineering. And so I kind of then started investigating more specifics on I used to be very interested in more engine stuff. That's something I want to get back into actually at some point, but since we're doing an EV, I haven't really had a whole lot of opportunity to work on internal combustion stuff. But just doing all sorts of reading on braking effective pressure. There's some good YouTube videos on that, or turbocharging. I was super interested in how do you take an engine and flow more air through it and make more power. What's all involved in that. There's some really good books on that too, like Maximum Boost by Corky Bell. That's a good one. So yeah, going into university, I maybe had a little bit of, I'd spent hours and hours digging through, forums and YouTube videos to learn as much as I could, but I would say the vast majority of what I've learned has been from other members on the race team, who were a little bit older than I was. So when I was joining the team, they were already, had already been on the team for a little bit, and they taught me just about everything I know about suspension, like at least getting me into like understanding all the concepts, like what is camber, what is caster, what is kingpin inclination, what's a camber curve, and tire load sensitivity, all these things that come up pretty often in race cars and suspension design that I kind of all learned from them. And then they also pointed me at some really good resources to kind of do my own learning, and I've actually started a collection of racing car like design books.
Right.
So I've got like,
oh, I see.
I have spent way too much money on that, but it's like there's lots and lots of really, really good books out there on race car design.
I see. So being the leader for the suspension team, how do you generally manage your team, and is it like a traditional like hierarchy, or do you guys kind of like kind of just go like you guys are all like almost equal in terms of the hierarchy? Like how does it work there?
Yeah. I mean, I don't like to enforce like a super strict, like I'm the boss. And everything I say goes, and you guys just, do the work for me. There is maybe some merit in that you wouldn't have to think quite as hard. I think if I was like that, maybe you wouldn't have to think as hard about what you were doing, and you could just, design whatever I told you to design. But I definitely value having people on the team who can argue with me and who can come up with other ways of doing something. Like if I propose, so it's like sometimes I'll just frame questions as like, here's a problem we need to solve. I have some ideas on how we might solve it, but I want to hear what you guys think, like what the best way to package this component is, or where we should mount this component, or anything like that. With suspension, you have a lot of freedom. In the FSA rules, you have a lot of freedom to do some really wacky things. You got to be careful that you don't like end up doing something that's so outlandish that it's not actually like feasible or it's going to get done. But in terms of like hierarchy, I think I try. This is always inevitable with an FSA team that like you can't have 100 people in a subsection all working on different things, and at the end of the day, you're going to struggle to get enough people who are actually invested and willing to put some time in to design things. But usually by the time we're on to like finalizing design choices and stuff, I'll have a handful of people with me who are as passionate about it as I am, and who are willing to. I'm hoping we'll find some people who are willing to argue with me on things and put their own ideas into the car.
I see. So how did you actually end up picking or going towards suspension?
Yeah, that's an interesting question. I don't know. It just, maybe it was the fact that when I went to that first year, like that first meeting, and we got pitched like all the different subsections and the projects that we could work on in them, it just, I don't know, it would just seem the most interesting to me. I mean, to be honest, maybe if we weren't doing an EV, the powertrain might have been what I had gone with, just because I know going into my degree, that was kind of the thing I had been the most, not that I had a lot of knowledge on it, but like it was probably what I had the most knowledge on. But I don't know, there's just something about like the physics of it all, and like how it's, you know what, probably what it is I owned a Miata. I had just bought a Miata when I joined the team, and it's like the whole ethos of that car is, yes, it has no power, but it handles so well that you can actually make it around a circuit in a decent time.
Oh, wow, okay.
And that all comes down to the suspension.
Yeah.
So I think maybe I was just curious that like, I want to understand how my own car like does that so well.
That makes sense.
And yeah, I've kind of, it's my thing now. Like it's it's kind of what I like doing.
Yeah.
Yeah.
Do you still have your Miata?
Yeah, I still have it.
So do you drive that to campus?
Man, I really should. It's kind of, it's an ongoing project, so it's not always the most roadworthy.
I do remember you mentioning how your brakes are a bit messed up for your car.
That might have been on my other, that was my other car, yeah.
How many cars do you have?
Too many. No, I just have two right now. One's reliable and gets me to school, and the other one is a Miata, and it's, it works sometimes.
So are you graduating this year, like at the end in May?
So because I'm in co-op, this takes 5 years to get through, so I graduate in 2026.
And how many co-op placements have you done so far now?
So I did my 4-month, and then I just finished up my 8-month. Yeah.
So now, in terms of the experience in the race team versus co-op, which one do you find more? I mean, I guess valuable isn't the right word, but like which one did you enjoy? Yeah, which one? Yeah, like did you learn more from or something?
So that actually is interesting. They kind of go hand in hand because I got hired at my co-op because I was an FSA student.
Oh, okay.
And a lot of what I've learned at my co-op is kind of, especially over this last term, has like kind of gone hand in hand with what I do on the team. So I work at restoration design in Guelph. So we're like Porsche and BMW kind of, we sell sheet metal is the main part of the business. So like if you have an old Porsche that like you can't buy body panels for it anymore and you need to restore it, there's tons and tons of those old cars now that are in various states of disrepair. So you can buy panels from us and restore your vehicle. What I was doing specifically though during my first term was wiring harnesses.
Okay.
So again for Porsches and BMWs, but reverse engineering the old crusty harnesses that we get out of customers' cars and rebuilding them with we rebuild them to be as accurate as possible to the original, but we're using some slightly more modern materials that last a lot longer and are a little safer, I think. So I spent my first co-op doing that, and then over my last co-op I've been working at the same place, and in addition to some of the wiring stuff that I'm still doing, I've been doing more like product design, and then I've been suspension design as well for like one of our personal cars at the shop. The owners wanted a push rod suspension in the rear of it, so as well as like we were doing a bunch of ridiculous stuff to that car. It's just kind of going to become just a really absurd vehicle, I think. So I was kind of designing the rear suspension of that. It's maybe not the most like practical design because you don't actually really need push rod suspension on a road car, but it will look really cool. Is I think the main thing, and I've done my best to make it like functional, safe, and that it's actually doing something for the car.
Right.
Like, so you see so many projects on like YouTube or whatever where I put F1 suspension in my road car or whatever. Or like, I'm trying to not do that as much as I can. Like, trying to make it actually practical and useful. Sure. But there's only so much. Yeah. There's only so practical. You can only make a push rod suspension so practical. It's not necessary at all for that car, but it will look really cool.
Yeah.
Yeah.
So what are your plans after like graduating university?
Yeah, I mean, I have some plans. We'll see how that works out. But currently, I'm trying to do either my next like summer's co-op or at least one of my terms before I graduate. I'm trying to get like an actual job in motorsport. That might happen, it might not.
Right.
Canada especially is a very difficult place to work full-time in motorsports because we don't have that many big teams, and even the ones we do, we don't operate in Canada over the winter. But nonetheless, I'm going to do my best to have an actual co-op job that's in motorsport. I was interviewing last year, so back in November of last year, I had an interview with Red Bull for the F1 team for suspension design. So that would have been for this past summer. Yeah. So they interviewed me and I think 5 other candidates for that. Wow. Unfortunately, I didn't get it. Yeah. One of the other 5 people got it, but
that's still very
it was still really cool.
Yeah. Red Bull, that's crazy.
So I was kind of hoping that would be where I was over this past summer. It wasn't, but there's no I still learned a lot this past summer. But they have also, all the F1 teams have these like graduate placements that they do where you spend a year working at the factory and doing all sorts of different, like, you'd spend a bit of time in like suspension design, maybe a bit of time in aerodynamics. You kind of go all over the place, and they'll try and find a place for you that you kind of would fit well with the team. Obviously those are super competitive, but I'll be applying to all of those when I graduate. My sort of backup plan is to do a master's degree in the UK. There's two schools. One is Oxford Brookes and one is Cranfield. Both of them are located kind of like within reasonable driving distance of Silverstone. If you're familiar with it's one of the most famous racetracks in the UK.
I see.
And so
is that where Gran Turismo happened? That's the only movie
oh boy.
I can think of.
I watched that movie, but was that...
I watched it too.
It was so cool.
Was he going around the Nürburgring in that movie? I very vaguely remember. I'm not super familiar with the actual story. Like, that's based on a real story.
Yeah.
Not super familiar with that. But he was from Wales, was he not?
Yeah, something like that.
There was probably at least one part in that movie where he was going around Silverstone.
Yeah.
But it's where the British Grand Prix is.
Okay.
And then just because of the history of F1 that it kind of got started in the UK, most of the F1 teams are actually based in the UK, despite, like, Red Bull, for instance, they race under the Austrian flag, but they're actually based in Milton Keynes in the UK.
Okay.
Did you bring that up in your interview? You should have brought that point up.
I think I did.
Maybe they were startled by how much you know.
Maybe they're just a little creeped out. I was actually reading, Adrian knew he's not actually at Red Bull anymore. Or, well, like he is until he's on gardening leave. Anyways, he's joining a different team for next year. He's joining Aston Martin. But I was actually reading his book, like, as I was preparing for the interview. And then they got started and they're asking me, do you know what Red Bull is or whatever? And I'm like... Yeah, I'm pretty familiar. I'm pretty familiar with what you do as a racing team.
That's really cool.
But yeah, so basically, there's these two colleges, and I think they're maybe universities, but I know in Canada that there's a distinction there. I'm not sure exactly how that distinction works in the UK, but they're smaller universities. They're not like the big ones that you would think of when you talk about the universities in the UK. But because of where they're positioned, being like kind of really close to the F1 circuit and a lot of the F1 teams, a lot of the professors are from the industry, and the courses are really tailored to like they have motorsport engineering courses where you would do a master's degree specifically in motorsport, and so where we do our 41X project at school here, or like for anyone not from Guelph, like our final year design project, they do a similar thing at their school, but it's like in racing, like for an F1 or MotoGP or a WEC team. So that's kind of where I hope to end up. If I don't get into like F1 right away, then I'm hopefully going to do something with a master's degree, which would kind of position me in a good place for that. But that's all for design engineering, if that's something I want to do. But I'm finding more and more that design engineering is actually like motorsport engineering. Well, so let's start with there's engineering in general. Automotive engineering is already kind of a niche inside of engineering. Motorsport engineering is like a very small niche inside of automotive engineering, and then you've got motorsport design engineering, like being the guy we use SolidWorks on the race team, but like in industry they'll be using Siemens NX. Very simple, like a CAD package, and you're the engineer who's there designing parts and designing the stuff that gets put on the car. That's actually like a very, very, very small group of people. And very, very few racing teams worldwide actually employ full-time design staff. Most race teams are concerned with running the car year after year, not designing and building a new one every year. F1 is maybe the most well-known racing series where that actually happens, where every year they're designing new parts for the car, and every few years they're designing a whole new car, and that's kind of what makes it such an interesting sport to me, I think, because it's not only competitive driving, but it's competitive design
as well.
And that's, I think, kind of to a much, much smaller degree, or much smaller scale. That's kind of what we're trying to replicate with the FSA program. I think that's kind of the whole goal of that program, is to kind of get engineers familiar with this whole what's the motto? Design, build, compete. Is I think their motto. So that exists in F1. What I'm finding is that same level of level's not the wrong word. It's just a different world when you're dealing with production-based race cars, whether you're doing GT3 or even some of the other formula cars, anything lower down the ladder from F1. the race teams are not designing those cars.
Right.
They're buying them and racing them.
Right.
So that's where the engineers that those teams employ are less concerned with designing. They're more concerned with analyzing data and setting up the car and basically looking at a race weekend or like the practice sessions and using their engineering skills and kind of applying a lot of engineering to make sure that car is as fast as possible on Sunday or Saturday for qualifying, Sunday for the race. So that's a very, very different job, but it's something that I'm kind of starting to get really interested in. And just the vast majority of motorsport jobs are that.
Right.
So I will not be, I definitely would not be sour if I ended up working in that, because I find that also very, very interesting.
Yeah.
And that's maybe a little more feasible for, anything outside of, I think, you have F1, you have some of the hypercars racing in the WEC, but not all of them anymore, because LMDH is a new series. I'm really going in the weeds here, aren't I?
Yeah,
but there's the F1 cars, some of the endurance cars, and then like hill climb cars are all cars where you can design parts for them and like just design something really crazy that just has to be within the rules. Everything else, every other racing series pretty much on the planet is going to be, use your engineering to make it as fast as possible. You're not designing anything. So that's what I want to get better at. Sort of focus at least some time into learning those skills. The plan is after my degree to do something in motorsport, which is difficult, but we'll see see where it ends up.
I'm pretty sure you could do it. Yeah.
I like the optimism.
Yeah, no, gotta be optimistic. Do you think if you were in the design part of the team, would you ever get intimidating having to do like something new every single year?
Yeah, I mean, intimidation, maybe. Like, I think for us as an FSA team, it can be intimidating because we don't know what we don't know. Like, we're trying to design parts that are, always better and better than the parts before, but like, we don't really have the same facilities or manpower or budget to do a lot of testing. Mm-hmm. So we do whatever testing we have, and that's actually a big focus, I think, this year, is we want to do more testing because those results are worth a lot when you go to competition. You're actually presenting your findings to the judges. If you don't do any testing, you don't have any numbers to back up, the parts you designed. That's not really engineering. Right. And actually talking to some of my older relatives who are professional engineers, like, it's a big thing that separates, students from professionals is, as a student, you don't test what you design, really. You just design it, you build it maybe, and that's that. Yeah. But actual engineers, you have to test your stuff, and a lot of times you have to test it to failure. Right. You're not going to know when it's going to break if you don't test it until it breaks, and then back off from that test case and know that it's going to be reliable when you don't stress it more than that. So for F1 teams, you have the budget, you have the facilities to do that, and that becomes very, very, very important when you're working with things like carbon fiber. I see. Where you can't just build it and hope that it will, behave the way you think it will. Any tiny voids in the the resin that they use to harden it, even just like the alignment of the fibers can affect the properties of it. So F1 teams, I think, do a lot of testing on really every part of the car, but I think where that testing is really standardized, and maybe you could argue where it's the most important, is the safety cell of the car. So most racing cars at like high levels of motorsport where they're going really fast now have like these carbon fiber safety cells surrounding the driver, so that in the event of a collision, it's designed to absorb enough of the energy to save the driver from like fatal injuries, which is, now unfortunately there has been a couple, like a handful of fatal injuries in like F2 and some of the lower Formula series, and like things like Colin Breen died in the last rally season, but like it's like obviously it's really, really unfortunate that there's still some people dying in motorsport, but for the most part it's become significantly safer than it ever has been, And a big part of that is now like the testing and the validation that goes into safety crash structure design.
Right.
That's actually something I'd be really interested in like learning more about.
Right.
That is, it gives you some degree of certainty about your designs. You can put some numbers to it, and you can actually have done some real world testing to know that the parts you designed will behave the way you want them to, will break when you expect them to. It's not about designing something that doesn't break, it's about designing something that you know when it's going to break.
Yeah.
So I don't think I'd actually be too nervous about designing parts. You know, if you're in a environment where you have the facilities to verify your decisions.
Interesting.
Yeah.
Very cool.
Very cool.
Very cool.
Yeah.
Do you have any other questions, or should we?
Well, we're almost at what, 36 minutes. That's
it's
a while.
12:37.
Well, no, 36 minutes up there. If you could go back to when you were younger, is there anything that you would do differently?
Maybe not watch those YouTube videos, or
No. I really don't regret that. I'm just saying, like, it's maybe not the most like technically enriching content, but it's like it still gets you excited about cars, which is super important.
And that's where you'd say you got your passion from, right?
Yeah, like
exactly.
I mean, I was always interested in engineering, but like I didn't really have a whole lot of direction in that. Like I didn't really have a specific thing that I wanted to point my engineering. You know, I'm not gonna say skills. As a 14-year-old, I didn't have any engineering skills, but like, you know, like I didn't have like something that I wanted to pour my passion into necessarily as a mechanical engineer. But now I think I've definitely acquired some sort of taste for that. But if I could go back and change something about like when I was little, if I could do something differently, it's always interesting to think of like what would have happened if maybe I was doing karting or something as a kid.
Yeah.
So you didn't do go-karting?
I did not do any go-karting.
Really?
No.
I was gonna ask you if that's one of your hobbies or not.
No, it's something that I'm looking into getting into now, but it's expensive. I think that's just kind of the main thing of it is. As a kid, I didn't come from like a rich family who, well, neither of my parents are interested in racing at all. But like even if they were, I don't think they had money to put me into karting. But it's just an interesting what if of like, you know, had I, you know, done karting, would I be a driver now instead of an engineer? Yeah. It's always an interesting question. And also just like had I been exposed to cars more, or like maybe race cars particularly from a young age, maybe I would, you know, I've just gotten into this a bit sooner. But really, I mean, like, I feel like a lot of engineering skills kind of, there's so much background knowledge that you need to kind of have built up to, you know, just math, right? Like math and physics that you need to, you know, get into. I mean, like, you know, maybe I could say that it would have like affected the trajectory of my life a little bit, but really probably not so much. Because I'm learning what I can now. With you know, how mature I am. I don't know that I could have really accelerated that a whole lot. Like, in life. The only thing I would say is maybe like being closer to race cars as a kid, I would have just. There's a lot of things I'm learning now, like just you know, this past summer even like going to races and just helping out like with some smaller teams. Like there's just lots of little things and procedures and you know the tools and you know even just like stuff like turning a wrench. I've been doing for a while now, but like had I been doing that younger, maybe I would just have acquired more like random skills and stuff.
I see what you're saying,
But from an engineering perspective, I think I'm kind of where I can be, where I always would have probably ended up. Yeah.
So if like say someone, what would be your advice to someone who wants to like go into the path you want to go into?
Yeah, I'll be a little bit wary about giving advice just because I haven't made it into the industry yet, and so there's definitely
you're doing great. Give yourself credit.
Give yourself credit. I definitely have some blind spots. So if anyone's listening to this and you want some advice, listen to me, but also like try and like go seek out some actual advice from professionals, industry professionals. But first things first, like join an FSA team. That's probably the best thing that you can do, and I think a lot of Formula One teams like actually like encourage their students who are interested. Actually, first thing you should do, go to like your favorite F1 team, go to their career page on their website. They usually have a paragraph or two in there about like hey, I'm like a high school student, what do I need to do to like work in F1? They have a pretty good breakdown of that. So I can echo some of what they say. One is just try and get a good baseline degree in like mechanical engineering or aerospace engineering. There's always more and more jobs actually coming up too in like the software and the electrical engineering side of things in motorsport. That's constantly growing. So I guess don't think that mechanical engineering is the only way in. It's just it's a good way. So start with a good engineering degree. You don't have to jump right into. There's some Bachelor of Motorsport engineering programs right now.
Oh, cool.
A lot of the advice I get is to not bother with those because you're kind of forcing yourself into a corner where it's I guess the hard truth of motorsports is not everybody who's passionate about it gets to work in it.
Yeah.
It's just such a small world.
Yeah.
So if you corner yourself into a motorsport engineering degree, you might actually not be able to do much with that. Whereas a mechanical engineering degree, you can do so much with mechanical engineering. We always joke that actually the mechanical engineers just steal everybody else's jobs, not even the mechanical ones. So I would start by pursuing mechanical engineering. Also, if anyone listening isn't as like inclined to do engineering, that's not the only aspect of motorsports, right? I've actually seen a lot of people have pretty good success with like even stuff like running social media accounts for motorsport teams or being a photographer or in fact there's even jobs in like transportation and catering and stuff. So if your main goal is just you want to be in the motorsport world but like you don't necessarily want to be an engineer, like just whatever you're passionate about, I think there's probably some way, just be creative about it, there's probably some way to apply it to motorsports and you'd maybe be surprised at what kind of career options there are out there. But I'll maybe speak more for the engineering crowd because that's kind of who I understand a little bit more. Join an FSA team, absolutely. Pursue like mechanical or aerospace engineering if you're gearing up to finishing high school and you're kind of looking into degrees. Those are definitely the two biggest options. Race cars are essentially just upside down airplanes, so aerospace engineering is super applicable to that. One bit of advice that I read from Paul Van Valkenburg. He's like a pretty famous race engineer who wrote a few books. One advice that he had that I actually think is kind of interesting is buy like a really cheap junky car and drive that every day and work on it because it will break down on you and you'll have to fix it and you'll learn so much just by wrenching on your own car.
For sure.
A lot of the most talented people I think we have on the FSA team kind of have a head start in working on vehicles because they have been fixing their own car for years now. And like, before I joined the team, I rebuilt my engine on the Miata. I've done a lot of work on it. So like, there's a lot of those skills. They're just applicable for mechanical engineering in general. You learn how machines go together and how they work. So yeah, buy a crappy car, go to a university that has a good mechanical or aerospace engineering program, join the FSA team, like pour everything you have into that for a few years and you'll end up exactly where I am right now. And then I guess go from there. Also, the last bit of advice, this is maybe the most obvious one, but like maybe actually probably the most important one, is do some research onto who your like local race teams are. Like what's your nearest racetrack? Like for us, it's probably motorsport is probably the nearest big one, and just go there to like every event that you can. And if you're lucky, like places like motorsport, we're super lucky here that they have a very lenient open paddock policy where you can just walk around, talk to any of the teams, and look at the cars up pretty close. So hopefully your local racetrack has like some similar policy there, and just go to the local track at an event where there's going to be lots of teams there, and just walk up to everybody and start handing out resumes. And more than likely they'll be super nice about it. Actually, one thing I found is like in motorsports, everyone is just like super nice. They might not give you a job right then and there. Hopefully they'll take your resume and be nice about it. But if you do that to every team on the paddock, maybe one of them is gonna take you on for the weekend and let you just help out, and then get their email address, email them the next time they're coming around that track or in nearby track that you can drive to, and just see if you can do that one again. Like that's kind of what I've been doing, and it's worked out actually fairly well. Like that's where you're going to learn like the actual ins and outs of motorsports.
Okay.
That's great.
Yeah, that's
that's
great.
Yeah. You need to come back in a couple of years when you're like a working professional.
Yeah,
you gotta like do a comparison of your advice.
We'll do a comparison. Maybe I can give some feedback on my own advice in a few years, or maybe that's the last you'll ever see of me.
Yeah, because you're gonna be so big and you're gonna go.
I was maybe going. Maybe I don't end up making it.
No,
and
you
we're not
will
gonna
make
come
it.
back to
Think
this.
positive. You're gonna make it.
Yeah.
Okay.
Okay, I think
that was very great. Thank you for coming.
Thank you so much for coming. Yeah,
taking the time.
Yeah, that was really good.
And yeah, stay tuned for the next episode.
Stay tuned for the next episode. I don't know if we'll beat this one, but yeah.
Okay.
All right. And I hope to see you on the next embedded meeting.
Yeah, I'll be there for sure.
Cool. Now you gotta go.
Yeah. I'm gonna be there. Okay. Yeah, I'll go.
All right. Well, thanks for having me. That was awesome.
Thank you for coming.